We're going to do it for this.
All right, iterators. Who needs help with the iterator?
Some talking.
Okay. 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 The first thing that you're going to start to get confused about if you're hearing this and like looking in the book and seeing all this is that I use the word iterator like 100 times in like all these different things. An iterator is equal to an iterator. All right. So just bear with and hopefully it'll all make sense. All right. Most people just want to know what an iterator does in the first place. So just to kind of, do you guys know what a for each loop is? Like regular for loop, but it's a for each loop. If you guys have never used a for each loop, you should definitely use it where you can. A for each loop, a regular for loop. Let's just talk about that first. So if I wanted to loop through an array of a certain amount and print out everything in the array, what would be the loop? What would be the for loop I write for that? Yeah. So how would you write it? Tell me exactly. Int I equals 0. Right. Then what?
Max size.
I what?
It must be less than max size.
Less than max size? Not max size.
Or just capacity.
Array dot length. Dot length. And then what? I plus plus. Okay, and then how do you print out what's in the array?
Just print.
So print, we'll just write print, that's pseudocode. Print what? Array at I. Right? Everyone understands this. This is straight up easy Java. Okay. The way a for each loop works, it's different syntax. You write it just like this. You say for. If you whatever is in your array, if it's strings, an integer. Okay, let's just call it strings. For string s dot dot and then the array name, which is array in this case. All right. For that, print s. That's a for each loop. All right. What this does is what this means basically is that for every spot in your array called array, take what's in that spot, save it as a temporary variable called s, and then do something in here, which is just print s. Okay. Print s. All right. So if you had like hello, hi, and welcome in your array, it would take the hello, put it as s, and then print s. Then it would go to the next one, which is hi, put it as s, and then print s, and then welcome, put it as s, and then print welcome. Does that make sense? Okay. So if you've ever used this before, even if you've never used this before, how does this work? Why does this work? How does it know how many spots are in an array? How does it know it doesn't run off the end of the array? You don't have something like this where you say go all the way through to array.length. How does this work? Well, this works using an iterator. In fact, any data structure that you have an iterator in, you can do a for each loop on. All right, so you can use this. Once you put an iterator in your system, when you're writing like a driver program, something like that, you can literally test and look at what's in every item in your list just by writing a for each loop. All right, if you make it, you can put it through. So we're going to talk a little bit further. For instance, I'll just tell you an example. If you guys haven't written a driver program yet, you're going to do something like this in your driver program. You're going to make a new, since your driver program is a class, you're just going to make a new instance of your class and you're going to use that. That instance has all the methods in it that you can do. So if you made the way you're going to do it is you're going to say a linear list ADT of type E of type string called list is equal to a new array linear list. Boom. Okay? So you're going to make a new object of an array, a new object of this array linear list you made, and it's going to be called list. Okay? Once you make this has nothing to do with the iterator yet. I'm just kind of starting to set you up. Okay? Once you have this list written here, then you can use list. This is an object of the class you created, and you can use any of the methods. So at that point, you do list dot add first. And these are strings. So you add first hello. Okay? Your list now has one thing called hello in it, named hello in it. Okay? You do it again. List, add last. And then you say hi. Okay? Your list, if you were to look at your list, which is this array that you created, it would have hello and it would have hi in it. That make sense, everybody? So you make a new object of your list, and then you list, and you can use any method in here. All right? If you were to now make a for each loop, of this list. And you say for string s in list, print s. This would print out everything in your list. Does that make sense, everybody? Okay, so once you have, if you have an iterator in this thing that you created, you can do this. And the question is why? Why can you do this? How does this work? And that's what we're going to go over. This is the best way I've seen to describe an iterator because it's a working example of what an iterator does. Right? So let's start. All right. An iterator is a class, just like your list is a class. So right up there, I made a new array linear list ADT list and set that equal to a new array linear list. Right? That list is an object, is an instance of that class you created. Right? So an iterator is a class. It is a class. And this class has certain methods in it, and it has a variable in it, right? So when you make this, once you make this iterator, okay, let's say you have an iterator. We're going to call it just IT. This is our iterator, right? You make this iterator. Don't worry about how we're going to make it. We're going to go over it, okay? This method iterator is an object of a class called iterator, right? This iterator has two methods on it, okay? It has a next method. This next method returns a Boolean. Oh, sorry, it has a hasNext method. Has a hasNext method which returns a Boolean. I'm going to move this up a little bit because no one's going to. Right. It has a hasNext method which returns a Boolean, and it has a next method which returns an object of type E. All right. These are the two methods that it has. Now it also has a variable in it. That's the index. Right? It doesn't have to be called index. It's going to be called whatever you make it to be. Right? So this is what an iterator object has. Right? Now this iterator object, this is what makes the for each loops possible. All right? The way it works is that if you have an array, and we're going to do this with an array first, and then we'll talk about your list. Right? If you have an array with A, B, C, D, E in it, and this is 0, 1, 2, 3, 4, these are the indexes. Okay? The first thing it does is it makes a variable called index, and it points it to the first spot in your array. Right? So index is equal to 0. So it's pointing to the first spot in your array. Then we're going to talk about what these methods do. The hasNext method, it's pointing here. So the index is pointing right here. It hasn't returned anything yet. It's just pointing right there. Okay? The hasNext method basically says, is there something that this is pointing to that I can return? Right? If the list was empty, if there was nothing in this list, or in this array, if there was nothing in this array, like that, and it was pointing here, it's basically saying, okay, is there something in this spot that I can return? And the answer is no. It's going to return false. This would actually return false in this instance. But if there was A, B, C, D, E, if it was pointing to something in this array and there was something there, this then would return true. Okay, does that make sense, everybody? Mm-hmm. That's literally what the hasNext method does. The next method does is a little more complicated, but just one step. These two work together. What the next method does is it actually returns what is in that spot, and it then it moves index up to the next spot. Okay? So let's just talk about how these two work together. Okay? If you wrote this, if you said, if in this while loop, in this array, if you wrote this piece of code, while it.hasNext, then print it.next. Okay, that's a perfectly valid piece of code. This is basically what a for each loop is doing. All right? It's saying it makes this new iterator. It points the index to the first spot. It says while it has next. That means while index is pointing to something where there's actually something to return, go ahead and print what it returns. Okay? This here returns that object. Okay? It prints out that object, and then it makes this go to here. All right?
If there is only one element in this.
No, if it's pointing at a valid object.
Oh, okay.
If wherever index is pointing, there's something here to return, it returns true.
Oh, okay.
Okay. So at first it says, okay, if it has an x, so if there's something there, go ahead and print that out and then move it to the next spot. That's what this does. Now it goes back up again. Does it have a has next? Yes, it does. There's a b there. So now it goes back in and it prints it up and moves it to the next spot. So now we printed A and B. Is there something here? Is there something here? Yes, it is. So it prints out the C and then moves it up to the D. Is there something there? Yes, it is. It prints it up, moves it to the E. Is there something there? Yes, it does. It prints out the E, moves it up to the number 5. Finally, there's nothing there, so it breaks out of this loop and it's done. Okay? That is what an iterator does. That is the whole point of an iterator. It makes your life so much easier. Now, let's talk about creating this iterator. Now that we know what both these methods do, let's write them. All right? So the method in your project, you have to write something public iterator type E called iterator. Boom, 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 boom. All right, this is the method you have to write. Okay, we are not going to write this yet. Okay, what this is saying is that there's a method called iterator, and it returns an iterator. It returns an iterator class. I know these are confusing because it's the same word, iterator. This is a method called iterator, and it's returning an iterator, like IT. It needs to return one of these objects that has all these methods in it. All right? So that's what it's doing. Well, let's not touch this yet. This is what you have to write. But what we're going to do is we're going to make something called an iterator helper. Right? And it's going to return that. So this needs to return an iterator, right? So let's give it an iterator. An iterator is just a class. So what you're going to do, you guys know what a nested class is, how it works. An inner class, a nested class, the same thing. You guys know how that works? Anybody not know how a nested class works? Everyone knows what a nested class is.
Oh, you can just go over it.
Yeah, absolutely. So if you have a class, like your class is a array linear list. Right? Okay? Everything is in here. You have your variables, you have your constructors that you made, you have all your methods. This is like add first, add last, all this stuff in it, all right? Before you get to the end bracket, you can make another class. And this is public, right? Public class array linear list. You can make another class down here called class iterator helper. Right? Class iterator helper. Type E, I think it is. I just want to make sure I'm getting my stuff right. What the hell is it? Iterator helper. Type E. Yes, correct. Okay. And this implements iterator. Oh, iterable. Iterable, right? It's iterable. Just want to make sure. I don't want to tell you guys the wrong thing. Oh, actually, after it's iterator. Oh, type E. All right. Okay. So what does implement iterator mean? So what is this here? What does this iterator mean? If this implements iterator, what is this iterator? What does this word iterator stand for? What does implements mean? Anybody know?
Interface.
It's an interface. So that means iterator is an interface. Do you guys know what an interface is? Have you ever used an interface before? You're all using an interface in this program. Your linear list ADT is an interface. What does that interface mean? If you're implementing linear list ADT, what does that mean to your project? That means you have to write all of those methods. All right? So since this iterator helper implements iterator, this means that this iterator has methods in it that you have to implement in this class in order for it to work. Okay? This also means, since this implements iterator, it also means that once you implement all these methods, this whole class is going to be of type iterator. All right? So the 3 methods you need to write. Okay, so I'm going to erase this. So now what we're going to do is we're going to pretend we're just going to write, so you have your class, public class array linear list, blah, blah, blah stuff. You have all this code up here. and then you finally get to this nested class. Class iterator helper type E implements iterator. Iterator. Type
Do we
E.
not have to put public before the private?
No, why don't you need to put private or public? Does anybody know? Okay.
Because you're already in a class.
Because you're already in a class. The only thing that can access this class is this class. You have no other chances. You don't have to put anything else down. All right. So you have your class. Now what goes in here? So it turns out that your iterator interface has three methods you need to write. It has a has next. It has a next, and it has a remove. Okay. These two we've already shown how to use. Right? We're going to go over it again. You're going to understand it better when we finish it. It's these two.
Iterator say? Implement?
Implements. These two you've already seen how we use them. This remove method, you actually don't need it in there. But that doesn't mean that you can't put it in there because it uses this interface. You have to put it in there. So what Professor has in the book, you can just do as is. You're going to see at the bottom there's a remove method. Down here it says like public void. You can see this in your book. Remove, blah, blah. And then all this method is going to say is throw new unsupported method, unsupported operation exception. You don't have to write this down, it's in your book. Okay. Throws new unsupported operation exception. It just means that it has to be in there, so you're throwing something in there. It never gets used. If it happens to get used, it's going to shoot out this exception that it's unsupported. Right? But this has to be in there, or you're going to get an error when you compile your program. Right? So throw this down the bottom. I'm not even going to go over this. It just has to be there. If you want to look it up, look it in the book. Put it in as exactly as it says. All right. So now let's get into the meat of this thing. All right. So there's two methods. There's a has next and a next. Now the first thing you want to do here is come up with two variables. You have int, which I actually wrote down as it index, it index. Just call it it index. And a int called, do I have count? We'll just say count. Okay. So what these are going to do, it index is going to move through your list. It's going to start at one point. So if you have your array, your list in this array, you have A, B, C, D. F is pointing here. R is pointing there. Okay. This is it index is going to start on the first spot in your list. So what are we going to set it index equal to? Anybody? What? Front. Or the first item, right? Is equal to F. If yours is called F, it's equal to front, right out front, whatever the heck you're doing. Okay. So it index is going to equal to F. It's going to give it the first spot in the list. Okay. And your count, you're just going to set equal to 1. Right. So basically, what this whole thing is going to do is kind of be kind of like all the rest of your methods. This isn't a hard concept to understand because you guys have already done this. That's why I recommend not doing this until like closer to the end, because you understand how this whole thing works. If you had to write this right in the very beginning, you'd be lost because you don't understand how your list works. You guys should all be experts at your list now, so you'll know how to handle this. Because what the index is going to do is just going to go through. Your has next method is going to stop at that index and going to say, is there something there to do? If it is, it returns true. If there's not, it returns false. That's all your has next method does. Your next method basically just moves it to the next spot and then returns what was in that spot. All right? So you set this up. So now let's go ahead and write our methods. Public. What does this return? What does your has next method return?
Boolean.
Returns a Boolean, right? So public Boolean has next. And you guys can write down this code as is. I'm going to try to make it as exact as possible. If I screw something up, I apologize. So public Boolean has next, and you got some stuff on here. Now, let's talk about this. If I is now pointing here on the very first spot, how are you going to tell if there's something in that spot? Give me an idea. Somebody throw something out.
Not null.
one option is not null. Okay? If that area, if that's in whatever's in that spot is not null, then there is something in that spot. That would make sense, right? Now, I'll tell you why that is not correct. It's kind of like actually what we were talking about before. You have A, B, C, D, E. Okay? You put 5 things in. You have front there and rear there. Okay? And then you remove 5 things. Okay? So that's when you remove 5 things, do we nullify these?
No.
According to your guys' code, do we null these out?
No.
No, we don't, right? All we do is set front and rear. Let's say you clear the whole thing. You set front and rear equal to wherever you have them starting, and your current size goes back to 0. All right? That's how you clear your array. Right? So if you ran your iterator now with this empty array, if your has next, so it sets I equal to where f is, so I is pointing right here. If your has next method says if storage at I equals null, return false. Is storage at I equal to null? No, it's not. It's not equal to null. So this would fail. It would think that there's something in the list when there's not. So we need another way to check and see if there's anything in that spot. All right. And the way we're going to do it is by using current size. All right. Your count starts at 1. Right? So you're on here when there's 1 item in the list. Right? Now, does it make sense that as long as your count, which is the first one you're on, is less, if you're increasing, if every time you go up, you're increasing it by 1, right? So when you're here, you're at 1. When you're here, you're at 2. When you're here, at 3. When you're here, at 4. Does it make sense that as long as your count is less than or equal to current size, then there is something in your list?
Yeah.
Does that make sense to everybody? So that's what you do. You basically say if count is less than or equal to current size, return true. Else, return false. Now, does this make sense to everybody? How this works? Does everyone understand how that makes sense to tell if there is a next item in the list? Is everyone good with that?
Uh-huh.
Okay. If there's not, let me know. I can definitely go or explain it a different way. So this makes sense. Do we like this code?
No.
What can we do differently?
Erase it and return count size, count equal to count size.
Less than or equal to current size, right? That's exactly it. Does everyone understand that anything in an if statement, anything in a while loop, that all is a Boolean statement and they're all on its own. This is going to return a true or false. So if this is true, basically what you're saying is if this is true, return true. If it's false, return false. So instead of doing that, since this is a Boolean expression, this is either going to be true or false in the first place, just return count is less than or equal to current size. Done. You have 1 line of code there. There's no reason to say if it's true, return true. If it's false, return false. Well, just return what it is. No? You understand that?
Oh, I was just looking. Yeah,
okay.
Got it.
Okay, cool. Because this simplifies a lot of code all over the place as you start to write more and more code. All right? So we're just going to put that piece in there. So return count is less than or equal to current size. Okay, everybody happy with that? Now you have half of your iterator done. There's only one more method to do. That's the next method, which isn't hard either. So basically, if you were going back to your iterator, okay, if it dot has while remember what we had, while it dot has next, print it dot next. Okay, so this part should make sense to you. While it has another one, all right? That means it starts off pointing to something. If there's something there to return, go ahead and return it. Goes to the next one. If there's something there to return, go ahead and return it. So that has next should completely make sense to you now, because you're telling it when it actually has a next. At any point in the list, you can see if there's another one. All right? So now let's move on to the next method. I'm going to write it to the side here. Public. Okay, what is next return? It has next return to Boolean. What is next return? A type E, right? Because it is going to return whatever is in that spot. This one returns a Boolean saying, is there something in that spot? And next returns an item that's in that spot. So it's of type E. You don't know what it is. It's generic. So you're just going to put type E. So public E, that's the return type. Next. Boom, boom. All right, how do we write this one? Okay, the first thing you're going to do, so if you're writing the loop yourself, like we just did that while loop that I said, the while was the check. It said while it has another one, go ahead and return the other one, all right? But there's nothing that says it has to be used in that fashion. Someone could make the mistake and basically just write, can just write pieces of code. You can just, okay, print it.next, right? Print it.next. They could do this 100 times. Want them to print out everything that's in that list, right? The problem is that this isn't checking it all if there is another one. So eventually, if you write enough of these, it's eventually going to go off the end of the list. Eventually, it's going to go off the end of the list, and you're going to get a null pointer exception. Does everyone understand why? Because the it.next isn't checking anything at first. It's just printing it out, go to the next one, printing it out, go to the next one. You can do that until it finally runs off the end of the list. So in your public E next, there's a catch for an error there. It's if has next. And it's you throw an exception. What is it? No such element exception? Yeah, throw new. No such element exception. Okay. Does everyone understand what that means in the front? Okay. This is a not. So if it doesn't have a next one, that's what this code means. Okay. If it doesn't has next, so if this returns a false, basically. If it doesn't have a next, go ahead and throw this out there. So this is kind of doing a last check for you. So that way you don't automatically get an index out of bounds exception or something like that. This is saying, okay, if it doesn't have a next one, if you forgot to check for it, go ahead and throw this exception. And this is what actually gets used on the for each. So okay, so this is your first thing. You copy this word for word. It's in your book. If I wrote it wrong, whatever like that, this is actually the first thing in your book. This is going to be the same no matter what kind of iterator you write. If there isn't a next, throw this exception. Then it comes down to the meat and potatoes of your iterator. So this is really the only thing you're ever really going to change is this section right here. And the reason why you're going to change it is because this part determines how you iterate through the array, through the data structure. If this was being written for an array, then it literally would just start at this whole thing would start at 0, and then you return what you move it to the next one, return what was there, and you keep doing that until it doesn't have another one. Arrays are super simple to write this for. But since you have a circular array, this whole array linear list, you have to write this a little bit differently. And the only thing you're doing here is determining how it advances through. All right. So remember, as you're going through this list, remember how before when you were printing stuff out, we saved something to a temp variable before we did it. Did we do that earlier? Oh, on the remove method, right?
Yeah.
Okay. We saved that to a temp variable, and then we moved everything. That way, it didn't matter where we moved everything. You still had the temp variable saved right from the very beginning. Well, every time through this list, you have to return something. This method has to return something every single time you run it. So what we're going to do is we're going to start it off the exact same way. We're going to say eTemp is equal to, now your I is pointing at where this is, right? Your has next check to make sure that I had something. Now we're going to remove what's in I, okay? Temp I is equal to storage at I. Now temp has it. You're good. You're 100% fine, right? 100% fine. Okay, so now all that's left to do is to move your pointer, to move your I to the next spot. So you've already grabbed I, now you're going to move it to the next spot, right? So in here, you're just going to write the exact kind of statements you wrote in your code, right? You're going to say if I is equal to what? What are you worried about when I is moving up the list?
Max size minus 1.
Yes. If I is equal to max size minus 1, what is I going to be equal to?
0.
0. Right? Else, what are you going to do?
I equals rear.
No, if you're in the middle of your array, if I is here,
Oh.
so you're worried, once I gets to here, let's say you had like another item here, E, F, and G, okay? If your I was here, you returned what was there, and now you're going to here. So you said if I is equal to the last spot in the array, go ahead and move I to here. What if I was here? What would you have to do? It's not at the end of the array. What do you do with it?
Move to the right.
Just move to the right one, right? So I plus plus. All right, so you stored it as a temp, you moved it where it needs to go, and then finally at the end of the day, you just return temp. Does that all make sense?
Why I equals 0?
Right here?
Yeah, that one.
Because this is how you've done it in all your other methods. I don't know if you've gotten to it yet or not, but if you're going through your array, if you're moving I to the next spot, like when you're adding, add last. Okay, when you add last, if you already have front, A, B, C, front here, rear here. Okay, if you're adding last, what are you doing with your R? You're not moving. If you want to add this, you're not putting R here and adding.
Right.
You have to move back to 0.
Right. Yeah.
Same thing here. So your I is going through the array. If I happen to be at the last spot, then you make it equal to 0.
Yeah.
If it's not, you just move it up by 1. It's the exact same code you guys have been writing the whole time. This is your whole entire iterator. Boom. This is your has next method. This is your next method. And the remove method I already gave to you. And that's honestly, if, I think so. Oh, the only thing we didn't add to this is that you have to increase the size. Current size, what did I call it? Count. Count plus plus. You have to increase your count. Because your count is keeping track of how many times it's going to go through this thing. As long as the count is less than...
Is that after you return temp?
Yes, after your... No, yeah, you're right. It's not after your return time. Very good. Count plus plus, return temp. All right, does this make sense to everybody? Okay, if everything I said makes sense, now let's talk about what this for each loop is doing again. And we'll think about the code that we wrote. Okay, so if we wrote the for each loop for E, so now our for each loop is doing what we have. For E, and we'll call it temp in list, because that's what we made. We made a thing called list. All right, print temp. Okay, let's talk about this with this list that we have. Okay. So when you make a new iterator, now one thing that I want to explain a little more is that this iterator is made specifically for your list, okay, and not specifically for your list structure, literally for this list. When you create this iterator, every time when you create it at a certain point, it knows your list at that point. It literally knows this list, takes index, points it to right there, knows how long it is, knows everything about it. So it is very specific to this list at that moment. All right. So when you say etemp of list, what this for loop does is it creates an iterator. It creates an iterator. It knows where the front is. It knows how long it is. It knows how to see if there's a next one in there, and it knows how to grab that next. That's what your iterator does. All right. So what it does is it creates an iterator. It says, is there something in it? Is there one? It starts at pointing at the first spot. It says, okay, is there something in it? Yes, there is. It's going to take it out of that first spot in list, stick it into this temporary variable called temp, and then print it out. All right? It's going to print it out, and when it prints it out, it advances it to the next one. So it goes to the next spot in your list. It looks again, is there something in there? Yes, there is. It takes it and puts it into temp, and then prints. And when you print out temp, when it prints out temp, it advances it to the next one. This uses an iterator. That's why anything you have an iterator in, any class you have an iterator in, you can do a for each loop on, which is really awesome. So in another assignment, you might have something where it says print out everything in your list. You could do it with these 3 lines of code right here, or 2 lines of code. All right? So now that we have this iterator helper, remember this is a class. This whole thing is a class. All right? So now let's talk about the actual method that you had to write in your class. You had to write public iterator type E called, and the method is called iterator. Boom, boom. Right? This method, all it wants you to do is return an iterator of type E. Right? We want to return an iterator of type E. Well, how are you going to get it? This whole class is an iterator of type E. Right? So if in here you just write return a new iterator helper, you're done. And the reason why this works, I'm going to explain why this works, if you don't grasp that. Okay. This is a class, right? This iterator helper, this whole thing is a class. It's a class, which means you can make an object of it. Okay, just like we made an object called IT. All right. How do you guys make a string? If you wanted to make a string called hello, how would you do it? Initialize it, set it to hello. How would you do it? Do you make new? How do you make a string in Java? String S is equal to.
Or just writing a string or.
You could just write hello, right? That's how you make a string, right? This is a shortcut. This is a shortcut that Java gives you because people make strings all the time. The correct way to make something of an object is string S is equal to new string, and in there you write hello. All right? So that's how you do that. That's how you make a string. You can make it like this, but this is the longhand way to make a string. Okay? If you needed to return a new string called hello, right? You can do this, and then just do return S, right? That makes sense, everybody? You need to return a string. Couldn't you just say return? If you're using this case, couldn't you write return hello? That returns a string called hello, right? Everyone, that makes sense, everybody? Okay. But you can also, if you want to use the longhand, you can return new string hello. That all makes sense to everybody, right? This is the way we're doing it. This is the way we're doing it here. Okay? You could, in this iterator, you can say iterator, so you make a new iterator of type E, calling it IT, is equal to a new iterator. Right? It's the same thing as a string. String is a class. You're saying make an object of type string, call it S, and make it to a new version of this class. Same thing here. Make an iterator class, call it it, and make it into a new iterator, because iterator is a class. You can call this class. And then you can say return IT, because IT is an iterator. That make sense? S is a string. You're returning that string. IT is an iterator. You're returning that iterator, because that's what it's asking you to return. So just like we shortcutted it down to here, we're shortcutting this on here to where we're just returning. There's no reason to make something called IT and then return IT. You can just return that new iterator. That make sense? All right. So this is the only line of code you need to write in your actual method that's in your the actual method that's in your class. You have to do this one line of code. But if you're going to do that, since you're returning this new, oh, I'm sorry, not new iterator helper. If that didn't make sense, I apologize. You're returning a new object of this iterator helper class that you wrote.
Do we need to cast iterator helper to iterator?
No, this is an iterator.
Okay.
Since this implements iterator,
so we don't need
it is an iterator. You're literally returning exactly what it's looking for. Okay? All right. And honestly, that's all of it.
But sometimes when we implement an interface, we just cast that to this kind of type.
Yeah, but since this what do you call it? Yeah, this interface Iterator, this isn't like iterable to where you can make it into something like that. This literally means that this is a type of iterator. So once you make this, it can be considered an iterator. Right? Any questions about this at all? Does this clear things up for you?
Yep.
The video? Yeah.
We're gonna post that.
I'll put it on YouTube and I'll let you guys know where it is. Yeah.
What's your YouTube?
It's actually this one's actually private. I have to if you want this video, write it down on the list. Give me your email address and I'll send it to you.
I got the piece of paper already.
Okay, does this make a lot of sense to you? Does this really help? Because iterators, to me, I think in TAing, a lot of people, so many people have struggled with the iterators, and they can look, and I know there's stuff in the book on it, and they kind of copy and paste, and they try to make it fit the way they want to fit. If you understand this the way I hope you understand it, you will know that any class you get, the iterator won't be hard to do, because the has next is pretty much the same as this all the time. As long as your count is less than how many items are in your list, you're good. This is the same. Throw a new element in section if it doesn't have a next. This down here, all you're doing is what you've already done before, is how are you going to advance your index through the list? And it's really that easy. So, any specific questions I can answer for you? If not, that's it. I'm going to give you a little tip for your project. You can use this iterator in multiple places in your project to make your life so much easier. All right? Let's say you had a method. I'm not going to tell you which method you can use this for. I'll leave that up to you. But let's say you had a method. He gave you a method, and you needed to print everything in your list. All right? So this is a fake method that you guys have to write. It's public void print. Print all. Right? In this method, if you use your iterator, if you didn't use your iterator, you would have to find out where f is. And then write this statement, write this whole long list to go through and, if I get to the first one. If it's max size minus 1, let's print out what it is, and then if it's a max size minus 1, I got to move it to the next one. If not, I++, and you got to do that whole check and do all this stuff. If you just use an iterator, you don't have to do any of that stuff. You say iterator, whatever, iterator E is equal to iterator IT, so this is, you're calling an iterator, you're calling an IT, is equal to this method that you have. You have a method that returns an iterator. It's called iterator, right? Is equal to iterator. You now have an iterator. With this one thing you just did, you now have an iterator of your class at that moment, right? So now that you have this IT, you can say while it.hasNext print it.next, and then you're out. This 3 lines of code prints everything in your list instead of having to go through and check things. Well, your iterator does all that for you. Now I'm going to give you a little insight into here, and this is something you're going to run into if you start using iterators, right? You did this. So you check to see if it had next, and you print it.next. And suppose you wanted, he said, to print it twice. Print it twice. So you write print it.next. Again. Does that work? Why doesn't it work?
It goes to the next.
Because it advances. Every time next is called, it advances. So you're basically checking to see if there is a next thing in there. Then you're printing, you're advancing it to what it is and returning it so that it can print it. Well, it is now advanced. If you started out, you printed out the A, right? This printed out the A and advanced it to the B. Now it does it again. It prints out the B and goes to the C. All right? So it is not printing out the same thing. Every time you .next it goes to the next one. So this could actually fail. If it was down at the end of the list, it's not checking to see if this second one has anything in it. It's just printing, and it can go off the end and fail. All right? So keep that in mind. Every time you write next, it is advancing. You can only use the next once. Now, if you wanted to print this multiple times, and I definitely pay attention to this, because although I'm not telling you how to use this for your exact code, it is almost identical to how you can do 2 of your methods like this with 3 lines of code. All right? So if you did want to print this twice, you can use that temp variable thing. You can say eTemp is equal to it.next. Right? Now you've only done that one time. Now you can print temp all you want. You can print it, do it 100 times, and it's not you've only advanced it once. Right? So you can use this. I'm telling you, you can write two of your methods that are actually two of the methods that people had struggled with a bunch. It cannot do the remove method. It cannot do the remove object method like this because it's not good enough just to go through and find something and do something with it. Yours has to know where that spot is and then shift everything down. So it doesn't work for that. But two of your methods can use this exact thing. Instead of doing print statements with this, you can do something else with these. And it works beautifully. It's really quick. So that's all I got.
Thank you.
Thank you.